Hello students, in this video we continue our discussion of infinite series. Specifically, we're going to take a look at what is called a telescoping series. Now in the last video, we discussed how to use partial sums to determine the convergence or divergence of an infinite series. Let's quickly review this important topic. Suppose we have an infinite sum n equals 1 to infinity of a sub n. Expanded, this looks like a sub 1 plus a sub 2 plus a sub 3 all the way down forever and ever and ever. So this is our infinite series. Now, instead of going to infinity, let's truncate this sum. That is, let's just take a finite portion of this infinite series. Let's just look at the first k terms. So if I want to look from n equals 1 to k, that then gives me a sub 1 plus a sub 2 plus a sub 3. But this time, instead of going to infinity, I'm stopping. And I'm stopping when n is k. This part of an infinite series is referred to as what we call the partial sum of the series. And this particular series stops at k, and so we write it with a capital S and a little k subscript. So now, let me arrange these partial sums, S sub 1 being just the first term in the series, S sub 2 being the sum of the first and second terms in the series, S sub 3 being the partial sum of just the 3 first terms in the series, etc., etc., etc. So if I take these partial sums and arrange them into an ordered list, what I've created is an infinite sequence. And the cool thing about that is we know how to determine the convergence or divergence of an infinite sequence. What do? We take the limit as k goes to infinity. So, looking at the limit as k goes to infinity of this kth partial sum, now what's really happening, right? We have this kth partial sum, and as we let k go to infinity, what's happening? Well, we're just getting a finite sum, but we're going to let k go to infinity, so doesn't this just give us back our infinite summation of terms up here? So, get this, so the limit as k goes to infinity of s sub k, if it converges to a sum s, well, that sum is actually the sum of the infinite series, n equals 1 to infinity. Therefore, if this limit exists and equals the finite number s, we say that the infinite series converges. On the other hand, if the limit as k goes to infinity of the sequence of partial sums, or s sub k, equals infinity, negative infinity, or does not exist, so if one of those cases happen, then we say that the series n equals 1 to infinity of a sub n that corresponds to that sequence of partial sums diverges. So partial sums are really helpful in determining convergence or divergence. In general, finding the sequence of partial sums, though, for an infinite series is not always an easy task. In fact, it's rather laborious, if not impossible task. However, there are two specific types of series, the telescoping series and geometric series, where the convergence and divergence of a sequence of partial sums associated to those series can be nicely modeled. So we're going to now take a look at some examples of telescoping series. Example 1. Determine whether the following telescoping series converges or diverges. If it converges, determine its sum. I want to take the infinite series n equals 1 to infinity of the cosine of n minus the cosine of n plus 1. So let's talk a little bit more about what a telescoping series is and how to recognize it. And in order to do that, I want to start listing out some of the terms in this telescoping series. So let me write out n equals 1 to infinity of the cosine of n minus the cosine of n plus 1. Now let's list out some terms in this series. In other words, let me start by letting n be 1, and then I will look at n being 2, and then I will look at n being 3, and let's see what kind of pattern might develop. If I was to start listing out or expanding this infinite series, I would get the cosine of 1 minus the cosine of 2. That would be my first term. Added 2, now let's put 2 in for n, and that'll give me the cosine of 2 minus the cosine of 3. That'll be my second term in the series. And then let n be 3, and I get the cosine of 3 minus the cosine of 4. But I just want to stop right here, because remember, this series goes forever. And what do I observe? Right away, I don't know if you notice, but do you see that things are starting to cancel in my series? Do you see that minus cosine 2 and plus cosine 2 cancel each other out? And negative cosine 3 and positive cosine 3 cancel each other out? Do you know what this is? This is an idea of a telescope. You know, like one of those cool spy glasses that pirates use. And then what you can do is you take this long telescope, and then what do? You smash it and condense it down, and then it becomes telescoped together. Well, that's kind of the idea with the telescoping series. See, I have all these terms, but they're canceling each other out in the middle. In fact, negative cosine 4 is going to cancel with the next term that I haven't written, etc., etc., etc. I haven't written the end of this, so hang on, let me write the end of this series. So, if I keep going, I get to the end of the series, which is when n is k. And so when n is k, I have the cosine of k minus the cosine of k plus 1. And now k plus 1, cosine of k is going to be canceling with the term before it. And so if I take this telescoping series and I take and smash all these terms together, what do I get? I get this really nifty, shortened, abbreviated two-term series, which consists of the cosine of 1 minus the cosine of k plus 1. Now, how nifty is that? Pretty cool. All right, and what is this? This was the partial sum S sub k. It consisted of just the first k terms in my series. So if I want to find whether this series converges or diverges, all I have to do is take the limit as k goes to infinity of this kth partial sum, which is the limit, which is the limit as k goes to infinity of the cosine of 1 minus the cosine of k plus 1. Now, as k goes to infinity, well, cosine of 1, that's just a number. Cosine of 1 radian, about cosine of 57 degrees. Okay, so it's close to, what is that? Close to a half, a little more than a half. Cosine of k plus 1 as k goes to infinity. Oh, what happens? What happens as the angle goes to infinity? What happens on the cosine? Do you remember? Cosine oscillates forever and ever and ever. Does it ever go to a limit? No, it always goes up and down and up and down and up and down. In fact, the limit as k goes to infinity of the cosine of k plus 1, actually, that limit does not exist, right? So if this limit as k goes to infinity of s sub k doesn't exist, what does that tell us about our original series? That tells us that our original series diverges. So let me write over here on the side, does this series converge or diverge? Well, this series diverges because it is a telescoping series whose partial sums diverge, or whose sequence of partial sums diverge. Does that make sense? Telescoping series are kind of cool, huh? So I think I'll save my next example for the next video. And in that video, we'll take a look at 2 more examples of telescoping series.